On March 11, 2011, an acute 8.9 magnitude tremor, referred to as the Great Sendai Earthquake or Great Tohoku Earthquake, developed in the northeastern coast of Honshu. Following the earthquake, the abrupt movements of the Pacific Plate had caused the water to become displaced, provoking an array of tsunami waves of intense severity. As the melted remnants of the fuel rods seeped to the base of the containment vessels, holes penetrated from the liquefied rods allowed the nuclear material to become exposed. Generated by the interaction between the zirconium cladding of the nuclear fuel rods and steam vented by the positive crankcase ventilation, all three reactors underwent a hydrogen explosion. According to the New York Times, the Fukushima Daiichi nuclear power plant produces approximately 400 tons of contaminated water per day, 3,519 containers primarily comprised of radioactive sludge, 3.5 billion gallons of contaminated soil, 1,573 nuclear fuel rods, 64,700 cubic meters of discarded protective clothing, 220 acres of deforested land, and 200,400 cubic meters of radioactive rubble. The Tokyo Electric Power Company is deliberating whether the 580 tanks containing 777,000 tons of contaminated water should be hurled into the Pacific Ocean. Although the Japanese government and the Tokyo Electric Power Company assures that they are devoted to the effort of disposing of the radioactive waste, this issue could persist for decades, with some recommending that Fukushima Daiichi be surfaced with a concrete and steel sarcophagus. However, by utilizing genetic modification, extremophilic microorganisms may allow the environment to acquire sustainability towards the radiation emitted from Fukushima Daiichi or detoxify various toxic waste sites. Recorded as the most radiation-resistant life form in the Guinness Book of World Records, the Deinococcus radiodurans is a polyextremophile bacterium which can withstand high levels of various types of radiation. By using a variety of gene clusters, the Deinococcus radiodurans could be genetically modified to significantly reduce the toxicity of mercury and toluene, an advancement for the treatment of radioactive waste sites. Theoretically, the Rhizoteuthis varionetis damage suppressor may dramatically improve an organism's cell viability towards the radiation emanated from the Fukushima Daiichi nuclear power plant. Environmental engineering offers a multitude of approaches in which may benefit the future of nuclear waste treatment, including the Fukushima Daiichi nuclear power plant.